Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the extraction, properties, and uses of tin and lead. In our last lesson, we learned about the extraction, properties, and uses of calcium. We learned about the production of calcium by the electrolysis of molten calcium chloride and by the reduction of calcium oxide by aluminium in a vacuum. We discussed some of the chemical characteristics of calcium. For instance, calcium reacts with cold water. It reacts with hydrogen at high temperatures, and it reacts with hydrogen and halogens. We also learned that it is important to include calcium in our diets because it plays a vital role in different systems within our bodies. In today's lesson, we are going to describe the manufacturing of tin and lead. We will also explain some of the chemical properties of both and describe some of their uses. Let us start by learning about tin. Tin is a silvery gray metal that does not bend or oxidize very easily. It is primarily found in only one ore, which is cassiterite. Tin is extracted from cassiterite by using carbon as a reducing agent. This reaction produces tin and carbon dioxide. While tin will not react with cold water, it does react with steam. When this happens, cassiterite and hydrogen are formed. Tin reacts with both dilute and concentrated hydrochloric acids. When it reacts with dilute acids, tin 2-chloride and hydrogen are the products. When it reacts with concentrated nitric acids, tin nitrate, nitrogen dioxide, and water are the products. Tin also reacts with halogens. It reacts with chlorine and bromine in the cold and with fluorine and iodine when it is warmed. In each case, the corresponding tin tetrahalide is formed. Students, write a balanced chemical equation for the reaction of tin with each of these halogens.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I am sure you were able to write a balanced chemical equation for the reaction of tin with chlorine, bromine, fluorine, and iodine. Please compare your equations with those on the screen. Let us continue by learning about some uses for tin. Tin is mainly used for electroplating steel, to make tin plate, and to make alloys. I'm sure you have seen tin plate many times because it is used to make cans for food. Tin is used for this purpose because it does not oxidize easily. This means that the cans will not corrode and destroy your food. When tin is used in alloys, it adds a desirable characteristic to another metal. Tin is a part of many metal alloys, such as bronze, solder, and type metal. Type metal is a combination of tin, antimony, and lead. Let us move on to our discussion on lead. Lead is a bluish-gray metal when it is freshly cut, but it soon tarnishes to a dull gray when it is exposed to air. It is a soft and bendable metal that is poisonous in certain dosages. The main ore of lead is galena, which is a black, shiny, and very dense substance. Galena can be separated from its impurities using the froth flotation method, which you have learned about in previous lessons. But how is lead extracted from galena? There are two methods. In the first method, the galena is roasted in air to produce lead-2 oxide. The lead-2 oxide is then reduced with coke or carbon monoxide in a furnace. In the second method, galena is partially oxidized by heating and blowing air through it. After a while, the air is turned off, but the heat is left on. The mixture proceeds to self-reduction. As we discussed before, when lead comes into contact with air, a thin oxide film forms on its surface. Because of this film, lead does not react with water. Lead slowly dissolves in dilute hydrochloric acid. When it does this, lead-2 chloride is formed. Lead reacts strongly in dilute nitric acid to form lead-2 nitrate and oxides of nitrogen. Lead does not dissolve in dilute sulfuric acid because a coating of lead-2 sulfate forms on its surface. Cold alkali attacks lead slowly, while hot alkali attacks lead quickly. Therefore, lead is amphoteric, which means it is capable of functioning as an acid or a base. Lead also reacts with fluorine in the cold to form lead 2 fluoride, and with chlorine in the heat to form lead 2 chloride. Students, can you describe some uses of lead metal? You may begin now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Lead is most often used to make lead-acid storage batteries. This type of battery is used to power automobiles. It is also used as an additive in petrol, paints, and pigments. You might also have mentioned that lead is used to produce lead sheets, lead pipes, and solder. In today's lesson, we learned about how tin and lead are extracted. We also learned about some of their chemical properties and how these metals are used in everyday life. This brings us to the end of the lesson for today. Until next time, thank you, teacher. Thank you, students.